Good afternoon. Today we are going to be working on 10.2. You're going to officially start your very first hypothesis test. And you will recall back in 10.1, we had a fellow student that rolled a very strange outcome of 12 times they rolled a 5, 12 times in a row. And we thought that was kind of weird. And there were two ways that we could look at that situation. So statistical significance, by definition, is when observed results from a random sample are very unlikely due to chance if the null hypothesis were true. So we reject the null hypothesis. What evidence did we use to spot our rigged die back in 10.1? So the classical method would be to look at the p-hat, which would be 12 out of 12, which was 100%. And find how many standard deviations away from the mean. And excuse me, give or take 2 standard deviations is our threshold, right? What we've said since day one in lesson 3.2, I think it's what it was, that if you were outside of 2 standard deviations below or above the mean, we are considered unusual. So hypothesis testing with the classical approach, we consider something very unlikely if the sample statistic is too many standard deviations from the parameter assumed in the null hypothesis. The other way we could say this is unusual is the p-value method. And this method says we could find out what is the probability of getting, so the probability of x being 12, right, when the probability of success is 1 out of 6. And we could do this in statcrunch and find out what this probability actually is. And then we would see if it's less than 5%. So let's go and do that. So we are in statcrunch, and we're going to go to stat and calculators and look at the binomial calculator and say, what is the probability that we rolled 12 dice and the likelihood of getting a 5 was 1 out of 6 or 0.16666. And we wanted to know the probability of getting exactly 12 of those. So all 12 of them had to be a 5. Wow, that is extremely small. Very close to 0. So let's just write that down. 4.5939 times 10 to the negative 11. Times 10 to the negative 10. So that is extremely small, which tells us that it's very unlikely. Okay. So hypothesis testing using the p-value approach. Very unlikely is if the probability or p-value of obtaining the sample result given the assumed null hypothesis is extremely low. So if the null hypothesis is true, that rolling a 5 is 1 out of 6 chances, then the likelihood of getting all 12 of them to be a 5 is this outcome, which is very small. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so we would definitely say that this is very unlikely. So a definition of the p-value, because we're going to use this p-value approach all the rest of the semester, is the probability of a fluke. And what is that? The probability of obtaining the sample result or something more extreme by random chance if the null hypothesis was true, as we assumed. Okay, we're going to use the p-value approach because that's our main method that most researchers are using now. So if you flip the page are actually all of the directions for your TI-84 if you want to follow those. And I would go to the gold sheets because this is one of those pages that didn't print out well. But we're going to actually use StatCrunch. So go ahead and flip the page to page 231. And let's look at our first hypothesis test. It says in a study from 2015, the Pew Research Center found that 24% of adult Americans paid for almost all their weekly purchases with cash. A credit union researcher believes the percentage has decreased since then. They conduct a poll of 1,068 random adult Americans and find that 18% of them make almost all their weekly purchases with cash. Explain what the study must have been an observational study and not an experiment. That's a great question. So if it were an experiment, then we would make people use cash. So you cannot make people pay with cash. So it had to be observational. What are the researchers' hypotheses? So they're right here. The percentage is equal to 24%. And what are they asking for? The poll, the information from the random poll, that's going to be our evidence. So we're not using that in the hypothesis. It says a credit union believes that the percentage has decreased. So we think it's less than 24%. Verify the requirements to conduct a hypothesis test are met. Recall, there are 210 million adult Americans. Okay, remember there are 3 of these. The first one is, do we have a random sample? Question mark. And they did say that they took a random sample right here of 1,068 adult Americans. The second thing is independence. And since we know how many adult Americans there are in the US, we can say that 1,068, our sample N, is at less than 0.5 of the population size. So 5% of 210 million adults. So 5% of that is 0.05 times 210 million is 10.5 million. So yes, 1,068 is less than that. Our normality piece that we have to meet, we have to look to see if n times p hat times q hat is greater than or equal to 10. And in this piece, you'll notice because it's a hypothesis test, so page 267 on your gold sheets, notice that this piece is not using p hat and q hat. It's using the p0 and q0. So we're not using, don't use those. It's p0 and q0, which is right here. Okay. This is P and this is P. This right here is your P0. Okay, so we're going to say N is 10,068. P0 is 0.24. It's not your P hat, it's your P0 from your hypothesis statement. And 1 minus that, and what does that come out to be? Is 194.8, and that is definitely greater than or equal to 10. So we can say that it's normal. Okay. Okay, so next says, test the researcher's claim that at the 0.01 level of significance, showing all steps work in graph. Okay, so you need to show me all 6 steps from our hypothesis test. Okay, you're going to rewrite the hypothesis statement, which ours is going to be a left-tailed because it's a less than. We're going to state our level of significance. We're going to find our test statistic, giving me this formula here. You're going to make sure to draw me the appropriate picture because it's left-tailed. We're going to draw the left-tailed picture. You're going to show me if you reject or do not reject in step 5, and then you're going to state your conclusion. Okay, so let's go ahead with step 1. From up above, we can copy that down. And that is P, let's see, H0, H1. P is equal to 24% and P is less than 24%. Our second step is alpha, and that's the level of significance. Those are equivalent, which is 0.01. And our test statistic is a Z0 because we're talking about proportions. And that is equal to this formula here, P hat minus P0 over, oops, I wrote this incorrect here. Sorry about that. It is P hat minus P0 over the standard error, which is the square root of P0 Q0 over N. So for us, that would be P hat, which is, they told us it's 18% right here is our P hat. So 0.18 minus 0.24 all over the square root of 0.24 times 0.76 all over 1068. That number will come out of StatCrunch. So just fill it in, but the number will come from StatCrunch. And then our fourth step is our picture here. And because it's left-tailed, it's going to be a left-tailed picture. And our fifth step is going to be our p-value. And we're going to compare that to alpha, which is 0.01. I'm just going to block this off. And then we're going to have our step 6, which is where we're going to actually state our conclusion. Okay, so let's go ahead and go to StatCrunch. And now the cool thing is we've been using StatCrunch all along for chapter 9, so most of this should look familiar. We're going to stat and calculators. I'm sorry, we're going to stat, oh, Mrs. Main, and a proportion stats. And we still have one sample, and we're doing with summary, okay? So stat, proportion stats, one sample with summary. And when we get there, we're going to put in the number of successes, and that we didn't calculate because they didn't tell us, they gave us the p hat. So we need to go back for just one moment and calculate this together. Oopsie, right here. Okay, so we need to find x because we only know the percent and n. So we need to know x. And remember that p hat is equal to x over n. And so we, earlier in chapter 9, I think is actually when we did this, we said we can solve for x by taking n and multiplying by p hat. So for us, we have 1068 times 0.18. That's our p hat from our sample. And so that comes out to be 192.24. And so we're going to round to 192 appropriately. Okay, so that's our x. So we are going to go back to StatCrunch here. And we're going to put in 192 and then tab and do 1068. And then it automatically is at hypothesis test, but make sure that you put all these in correct. So we have to change to 0.5 because ours is 0.24. And then ours is a less than. So make sure you change those parameters on your hypothesis test. And then you can hit compute. And this is what you should have come up with. And it should have been that our Z statistic is a negative 4.608 and our p-value is, it says it's less than 0.0001, which means it's very small. Okay, and so I want to make sure everybody has that written down. So let's go back to our course pack. And so there's our Z statistic, which means we are actually 4.6 standard deviations below the mean. Even by our requirements back in chapter 3, that is definitely an unusual event. But we're using the p-value approach. And so the likelihood of this weird thing happening, right, with adult Americans less than 24%, our sample had 16%, or I'm sorry, 18% actually paid with cash. That likelihood is less than 0.0001 or less than 0.01%, because there's our p-value right there. And this is negative 0.4608. And we would definitely say that this is less than, so we do reject H0. And so we're going to make sure that we write up our formal stating the conclusion. So we do reject H0, so there is sufficient evidence to support the claim that less than 24% of adults pay with cash. Okay, because it happened, the likelihood of this event happening is so small. It's less than what our tolerance is. Our tolerance is 0.01 or 1% tolerance. And so, and it did happen. That was our sample. Unless it was a weird fluke, right? There is sufficient evidence to say that we have less than 24% of adult Americans paying with cash. Yep. Okay, so let's go ahead and flip the page. And we're going to bring in some other things that we talk about when we talk about hypothesis testing. And one of those is called prevalence. Prevalence is the assumed in H0 proportion of a population that has a specified trait or condition. Okay, so prevalence would be our assumed P, whatever we think is true. Majority is majority or most means that we're going to have more than 50% of the population. That's a majority. So P is going to be bigger than 0.5, and a minority is less than 50%. So that would be P is less than 0.5. Okay. So let's read through some examples here. It says, write the null and alternative hypotheses for the following. A researcher for the Gallup organization believes that a minority of adult Americans have good jobs. So that would be here. So we're talking about minority means less than. So this is going to be equal to 0.5. And minority means it's going to be less than 0.5. B says, in 2019, Gallup released a poll that stated that a majority of Americans prefer a life sentence to a capital punishment or the death penalty. A criminal justice professor believes that the percentage that prefer a life sentence is higher in Michigan. Okay, a criminal justice professor believes that the percentage that prefer a life sentence is higher in Michigan. They believe it's a majority. Okay. And they believe it's higher than that. So this would be H0, H1. And this would be P is equal to 0.5 and P is greater than 0.5. So they think it's more than 50%. A majority would be 50%, and they think it's more than that. Okay, example 3 says, on July 19th, 2020, the U.S. had a COVID-19 prevalence rate of 1.15%. A researcher for the Jackson County Health Department thinks that this is not the rate in Jackson County. They take a random sample of 430 people in the county and find that 9 of them have COVID-19. Test the researcher's claim at the 0.05 level of significance, showing all steps working graph. Assume the conditions have been met. So we're going to assume the CLT conditions have been met. So we can go straight to our hypothesis statement. And they think the prevalence rate is equal to 1.15%. Our researcher thinks it's not the rate. So that's going to be a not equal to 1.15%. Okay. They want us to test the claim at the 0.05 level of significance. So alpha is 0.05. And so our test statistic, we're going to put in our X and N. So let's just make sure we have our X and our N. So X is, they took out of a sample of 430, they found 9 of them. So X is 9, N is 430. So P hat is equal to 9 out of 430. Which is 0.0209. Okay. Okay, which is a little bit higher than what they said. This is 2.09%. Okay, so we're going to get this from StatCrunch because it's going to be the P hat, which is 0.0209 minus 0.0115 all over 0.0115 minus 1 minus 0.0115 all over 430. And we'll let StatCrunch calculate this for us. Then the graph that we're going to draw is two-sided because we have a two-tailed test. And so our p-value that we're going to get from step 5 will kind of be split between these two, right? And the alpha that we're comparing to is 0.05. And then we have to make sure that we state our conclusion. So let's go to StatCrunch and put in 9 and 430. So remember, we're going to stat, and we're going to proportion stats, one sample with summary. And so we have 9 and 430 in the sample. And we're saying our proportion is, make sure you turn that to a decimal, it's 0.0115. And this is a not equal to, so we've got that, so compute. Okay, so there's our Z statistic. It's 1.834. Our p-value is 0.0666. And make sure you get that jotted down. And then we're going to go back to our paper to make sure we have all the same documentation. So there's our Z0 that we came up with from our evidence. And there's the p-value that is associated with that Z0. And in this case, it is bigger than our threshold, right? It's bigger than that. So we do not reject H0. So when we go to actually state the conclusion, we can say there is not sufficient evidence to support the claim that the prevalence rate is any different than 1.15% in Jackson. Ta-da, you did it. We have some wrap-up questions on page 233 for lesson 10.2, so let's go there. So our wrap-up questions here go back to the idea of statistical significance. And statistical significance is when observed results from a random sample are very unlikely due to chance if the null hypothesis were true. So we reject the null hypothesis. And let's remind ourselves the way that we reject, right, is we reject if p-value is less than alpha. So that's what we're checking out here. So it says, is a p-value of 0.06 statistically significant result at 0.1? So 0.06 and 0.1, it's less than, so yes. We reject. It is significant. What about, is a p-value of 0.06 statistically significant at 0.05? No, it's not, because it's bigger. Okay, so is a p-value of 0.04 more statistically significant than a p-value of 0.06? And that is yes. And that's because if, let's say you put an alpha in between here that is 0.05, this one will still reject. This one will not reject. So the lower the alpha, that means the higher your confidence is. So if you can reject at a very low alpha, that means you can be very confident that you're going to reject H0 and thus not commit a type 1 error. So right here in this course, we want p-values to be low, and the lower the better. So let's look at our last example here for the lesson 10.2. It says, suppose a given level of significance is 0.1. Which of the following p-values represent statistically significant results when performing a test with a significance level of 0.1? So anything lower than 0.1 is going to be significant, statistically significant. So that would be this one. And not those two, not equal to, so we can't count that one. It has to be less than this one, and this one. So those four. Of the p-values listed above, which is the most statistically significant? And so that would be the one that's 0.009, because it is the smallest. And then it says, of the p-values listed above, which one may indicate an error in how the test was run? And that would be this 0.992, because p-values are in the tails. And 0.992 is in the middle. So the smaller the p-value, the more significant. So the smaller, the better. That's important. The other thing to remember is to reject H0, you have to have your p-value less than alpha. That's what we're going to use in all of chapter 10 and 11. So enjoy reading the joke on the back on page 234. And I will see you in a bit for lesson I'll see you for lesson 10.3. See you in a bit.